Alright, this is part 3 of soil for the home for the plants. Plants, all plants require 17 elements, 3 of which are obtained through the air and water: carbon, hydrogen, and oxygen. Nutrients that are most frequently deficient in plants will be nitrogen, phosphorus, and potassium. Nitrogen, phosphorus, and potassium are primary macronutrients. The word macro means large. In other words, the plants need these in at least a couple percentage points or more, sometimes double digit, in their plant tissue in order to grow and function. The secondary macronutrients are usually needed at 1% or less in the tissue, but is still very, very important. Those are calcium, magnesium, and sulfur. Then we get to the right hand side and we call them micronutrients. Micro means small. Not that they're not important as the primary macronutrients or the secondary macronutrients, it just means they're usually needed in less than 1% or a fraction of a percent in plant tissue for plants to grow properly. Iron is probably one of the more common micronutrients to be deficient, especially in our alkaline or high pH soils. Manganese is another one we run into very frequently here in Florida. I don't see too much zinc or copper deficiencies. I don't think I've ever seen a copper deficiency that I can recall. Chlorine, another one that I can't think of a time I have seen a deficiency. I have seen deficiency of boron on a couple of plants, notably palms, which we'll talk about later in this program. Molybdenum. It took me 4 years in college and a lot of my parents' mind to be able to pronounce that word for you today. Nickel. This one was hotly debated when I was an undergraduate back in the dark ages called the 1980s. Nickel was thought to be necessary by some and not necessary by other scientists at the time. Well, some scientist somewhere designed an experiment and was able to produce a medium totally devoid of any potential of nickel in it, and in fact did discovered that nickel is needed in plants, but the amount is so little and it's so uncommon for it to be deficient in soils that it's one of those we would probably never supplement to plants through our fertilization processes. So, where do the nutrients of these minerals, these chemicals, come from in the soil? Well, they come from the minerals that are left behind from when the soil was created, the organic matter, which is very low in Florida in general, and of course from fertilizers that we supply to the plants. Plant nutrition and fertilization. There's some key points I wish you to remember. Fertilizer application where there is no plant response is unnecessary and wasteful. A lot of people do not understand that very simple tenet. If your plant is growing just fine and you're cutting it off, like turf all the time, do you really need to add more fertilizer to the system? We're not growing most of our ornamentals for the food production or super fast growth to be only mowed off and thrown away. Well, some people are. Fertilizer is not plant food. I know what bags of fertilizer say, but it is not plant food. It's plant nutrients. I like to think of fertilizer much more like vitamins are to us. We still need to eat in order to get energy. How do plants get their energy that they need in order to grow? That's right, photosynthesis is the key to all that. So it's taking the light energy and converting it into sugars that is truly the plant's food. So fertilizer is much more like a vitamin. We can't live by just taking vitamins. We still need to get energy in. So you never feed a plant. Plants manufacture their own food from sunlight and turn it into carbon materials they use for growth. All right, here's a graph of availability of phosphorus or nitrogen in the soil. Let's start at that's the axis at the bottom. Let's look at the axis going up called growth response. So here is a relative chart or graph of what's going on in our soil with plants with fertility. So starting at the left-hand side of the screen, we can see our native soils usually have some deficiency of either nitrogen or phosphorus or other elements for that matter, and plant growth is fairly, slow and steady. Plants in the woods don't get fertilization per se. They get their nutrients from the recycling of what fell in the forest down to the forest floor and what animals went did their thing, if you know what I'm saying, in the woods that returns those nutrients back into the plants. So their growth rate in the forest may be quite slow, but okay. Then we as human beings want to increase either food production or yield of plants for whatever particular reason. More flowers, if you're growing roses, for example. Darker leaves to be more aesthetically pleasing. Producing more corn in the same acreage or more corn in the same acreage that we did 50 years ago. Another potential reason. So we fertilize. At some point through research, etc., we find that there's an ideal or optimum range between adding phosphorus or nitrogen into the system or onto the landscape or into the field and optimum yield and growth. Again, when it comes to adding these inputs to soil, it can be very expensive, especially in farming situations. A farmer doesn't want to just dump on fertilizer if he doesn't need it or doesn't get the yield out of it because there's just the plant can only use so much. So we find that happy point. Homeowners don't understand this. They like to keep on pushing the plants. Or worse yet, when the plant doesn't look too good, they add more fertilizer to it thinking it's a cure-all. It generally is not. Then if we keep on adding more fertilizer to plants, whether it's your landscape, your lawn, or for that matter, field grown plants, we have something that's called luxury consumption. This is a very complicated concept that most people best if you can visualize what I'm doing. I'm patting my stomach, and you can kind of hear there's a bit of sound to it. That was luxury consumption on my behalf, or my part. Then, what can happen with certain nutrients, especially over-application, is it can become toxic to plants. This is especially true of those micronutrients if you over-apply them. A little goes a long way. So, I know we've talked pH before in the class. Whitney talked to you about that a little bit in Right Plant, Right Place. But I think it begs to rejoin this with seeing the pH scale once again. Our stomach is very acidic. It's probably a pH of about 1. That's what breaks down the foods that we consume and makes it easier for our GI tract to get the nutrients out of the food that we consumed. Meanwhile, we go across the scale from anything between 1 and under 7 is on the acidic side of the pH scale. Most plants function best between 5.5 and 6.5. Now you think neutral, it's neither acidic or basic. That's true, but that's not where most plants really want to be. They want to be on the acidic side of the pH scale. Now, some of you may have use the term to refer to acidic soil as sour. Think of lemon juice, very acidic. It's sour. Then there's basic. Anything between over 7.1 to 14 is basic or alkaline. You may also use the term sweet. I don't particularly like that term sweet because it connotates something that we naturally gravitate as a species. We naturally gravitate towards sweet things. Most of our soils in Central Florida are on the alkaline side or basic side or are sweet. Usually our typical soil pH is about 7.2 or thereabouts. It can vary depending on it, but most of our sandy soils are alkaline or basic or sweet. Now some people have come from areas of the world where they have sour soil and would add lime to the mixture every year routinely without testing the soil. It was just one of the basic tenets of their gardening and raising of their lawns. Well, let's think about this. When you have an upset stomach, where's your pH of your stomach again? Yeah, highly acidic. You do something to get rid of the acid. You use an antacid. So what's a common antacid? Something like Tums comes to mind. That's calcium carbonate. Calcium carbonate is also lime. It also is chalk. Now you know why Tums and similar products like that have a chalky taste. It is literally a stick of flavored chalk with some sugar. So adding more lime to already basic or alkaline or sweet soil only pushes the pH even more alkaline or basic. And like a lot of things, when you get to one extreme of the pH scale or the other, it starts to damage things. Things that are very alkaline, for example, something like lye would burn your skin, as would something very acidic would burn your skin, like battery acid. Most plants want to be on what side of that pH scale again? 5.5 to about 6.5, the vast majority. So when we see pH values at 8 or 9, that plant palette in that landscape is probably not going to be, it'll have to be chosen very carefully by the people. Here's what's really going on in the soil pH system. And just look at that 5.5 to 6.5 and just kind of go down. You see nitrates, nitrogen, potassium, aluminum. That's not a plant nutrient, but you see that there. Calcium, phosphorus is a plant nutrient. Iron, magnesium, sulfur, manganese, etc., etc. You can see the lines get thinner or fatter. That's a relative amount of availability at over the pH scale. So if it's a very narrow, it's less available at certain parts of the pH scale than when it's very, very wide. I'll be talking about some pH fussy plants in a moment, but most of those pH fussy plants, like azaleas, want extremely acidic soil. Blueberries are another classic example of a very pH finicky plant. They want a pH between about 4 to about 4.5 to 5. Well, let's look at that left-hand side of the screen. What plant nutrients are greatly available? Well, aluminum, but that's not a plant nutrient. Iron. Look how easily available it is to absorb iron at that very acidic side of the pH scale. Most of the other micronutrients are also available when it's extremely acidic. We notice the vast majority of key plant nutrients are available over a fairly wide range of pHs, nitrogen, phosphorus, and potassium specifically. Magnesium is too, so is sulfur. But then we get to some of these like manganese, which we have a lot of deficiency of manganese. I mentioned that earlier. And we can see that much above about 5.5, it is getting harder for plants to assimilate it. Many plants grow well in soil pH. I said 5.5 to 6.5. This slide says 7.5. That's not so true. But there are some that require much lower pH because they're iron inefficient. If you saw the last slide and heard what I said, is notice availability of iron is great when the soil is very acidic. So here are the pH finicky plants that you should really always know and keep in the back of your mind when people call that they're having problems with it. Usually these plants are foundation plants planted around our homes that are made out of concrete on a concrete slab and stuccoed over. What does concrete have a lot of it? That's right, it has a lot of lime. And lime does what to our soil pH? It raises it, makes it more alkaline or sweeter, a term you know I don't like. So azaleas, gardenias, camellia, ixora, loropetalum, hibiscus, blueberries especially, and pines. Now most people don't plant pine trees, but they may have them in their landscape left after the construction process. So have these hammered into your mind at some point because you'll probably be asked about them. Azaleas, gardenias, camellia, ixora, loropetalum, hibiscus, blueberry, and pines. They're all very pH finicky. All of them want about a pH of about 5 to 5.5 with the exception of blueberries that would prefer around 4 to 4.5 up to about 5. What is our native or typical Central Florida sandy soil pH? It's about 7 and something. So a lot of people know we grow blueberries here in Central Florida. This is true. We have selected certain cultivars for low chill to grow in our conditions, but they still require acidic soil. So how are they growing them in our alkaline soil in Central Florida? Well, the farmers, generally speaking, are not growing blueberries in the native soil. They're either growing them on mounds of pine bark is very acidic, or they're growing them in large containers filled with pine bark. Even doing that still has its problems because of the limited amount of soil, or pine bark in this case, available for the plant roots, and how we have to water blueberries since they're fairly non-drought tolerant. We're watering from water that came out of our aquifer system. Our aquifer is a limestone aquifer. The water pH, typically speaking, out of the tap is between about 7.2 to about 7.8. It can vary a little bit. That's why you have hard water and lime scale issues in your bathroom fixtures and whatnot. So in these systems where they're growing blueberries, if you're putting alkaline water on there all the time, the pH will eventually start to rise in the container on that mound of pine bark. So blueberry growers inject certain acids into the water to bring the pH down to around 5. This is something I would never advise a homeowner to do, is to play with acid. And here's an azalea looking rather sickly. When I get questions like that, if they're not recently planted and just not established, it's usually a pH problem, although there can be other things. Had this homeowner come into the office and gotten a soil test kit and send off his $3, check in there, he could have prevented this problem. He could have planted something that is very non-pH fussy. Oftentimes, the best thing to do with pH is not to mess around with it. A lot of people want to start adding things to the soil to change it. And while it's doable in some cases, it's probably best to choose plants that'll tolerate the soil conditions you have in your landscape or in the client's landscape. Now, some people will ask you about acidifying the soil. Can it be done? Yeah, but I generally advise against it. Again, what we use to lower the pH is elemental sulfur. How does it work? Sulfur is used by soil microorganisms. In the process of breaking down the sulfur, they convert the sulfur into sulfuric acid. Acid will reduce the alkalinity of the soil temporarily. Temporarily. So what happens is you may get it to lower a half a pH unit if you're lucky, and then once the sulfur is used up by the microorganisms, the pH will return right back to where it was. So adding sulfur is a roller coaster back and forth and creating acids in the soil, and that could damage plants if you over apply sulfur. Again, it would be far wiser to choose plants that are tolerant of those alkaline conditions rather than to try to acidify the soil. As far as acid forming fertilizers, they usually have a lot of sulfur. They usually don't lower the pH of the soil that very much. Lime, it supplies calcium. Sometimes some of our soils are deficient, and certain plants need a lot of calcium in order to grow. Tomatoes and peppers and squashes are a great example. You may have heard of something called blossom end rot. That is usually a lack of calcium in the cell wall, and the cells will collapse at the blossom end of the fruit. Again, lime, chalk, Tums, if you will, raises soil pH. This is generally something we don't need to do in Central Florida. So there's soil testing. A lot of people don't understand what a soil test is or what it ain't. I'll explain that. A nutrient is deficient if its addition as a fertilizer will produce a desirable plant response. That's pretty simple. The desired plant response depends on the purpose for which the plant is being grown. If it's beauty, adding fertilizer may make it darker green. It may make that plant flower more often. It may make for better, larger tomatoes or something like that. It will not generally help you when you are having issues with a quote sick plant. The desired response can vary from person to person, yard to yard, landscape to landscape. Again, fertilizer application where there is no plant response is unnecessary and wasteful. Why would a plant not respond to fertilizer? Think about wintertime. It may be in a semi-dormant or quiescent, kind of resting phase of its life and not able to absorb a whole lot of nutrients or do anything with them at that particular time of the year. Soil testing and plant nutrient management. Plant species differ in their ability to obtain nutrients from the soil. When the soil cannot supply all the plant's needs, it at least supplies a portion. Soil testing can help predict fertilizer needs. Really, a soil test is designed to tweak fertilizer recommendations to our clientele. Observation and records are also very helpful to see if what you put on is, in fact, doing some good. Soil testing consists of three parts: taking the sample. It must represent the area where it was taken. Let's say, for example, if you remember back to another section where that soil in that particular yard had a white area and then it was kind of a more tan throughout the rest of the particular landscape. If a client would have two distinctively different soil colors, or for that matter texture, some people have clay in some areas and may have sand in another, just because of the process of how the home was built or whatnot, or a larger piece of property, they may want to sample those independently because they will have different values for nutrients in them. So it's got to represent the area taken. Now I've seen homeowners take it to the extreme and they take 10 samples in a yard that's 2,000 square feet. You really don't need to go to that level of detail. Different laboratories, independent of the University of Florida, may use different testing methods that are not accepted by the University of Florida because of the extraction technique or method. Interpreting their results. I'll be honest, the soil test is not written for the average living, breathing human being. It's a big bone of contention for me, but we interpret those sometimes, and I or Dr. Whitney Elmore usually are the person to help the clientele with that. So here's how I might sample a yard. Let's say I'm vegetable gardening in one corner, or I have different soil in my vegetable garden because I've amended it with compost and other materials. I would sample that totally independently of my front and backyard. Again, would I put my backyard in one soil sample bag and the front yard in another soil sample bag and pay for two soil tests at $7 each? Unless that soil is really different, I would just take it from both the front and backyard as one sample. Now, if I had a big area of trees or shrubs that were very, very important and not didn't have any turf around it, I might send a third sample off. But in general, most people will not have trees and shrubs relegated to one little corner. They'll have them integrated into the lawn and their landscapes. And trying to fertilize trees independently of the turf really isn't practical. And as I'll talk more in this program, most trees and shrubs over 3 to 5 years of age in the landscape don't need to be fertilized independently of the turf. They're getting it from the turf grass fertilization. A routine soil test, if you only pay $3, will give you a pH and lime requirement. If you pay $7, you'll get the pH and lime requirement. Calcium will be documented, magnesium, phosphorus, and potassium. Those are the only elements that we test for. Notice this does not test for any kind of chemical residues other than those chemicals that you just see on your screen. Yes, those are chemicals. They're elements, but they're chemicals. So when the clientele asks you, will it test for why the lawn is dying? Probably it's not going to answer the question as to why the lawn is dying, because it's not designed to do it. It will not test for disease-causing organisms. It will not test for any kind of insects. It will not test for any kind of herbicide or insecticide residue or residues. This is only designed to test for those elements and help us tweak fertilizer recommendations. So a lot of times when clientele come in and ask for a soil test, I said, what are you hoping to find, or what are you hoping to learn from this? If they say, well, my plant is dying, I usually stop and say, let's talk about the plant and what's going on. And usually we have a better answer for them than what a soil test, which would be a waste of their time and money. Water, water solubility of nutrients in a fertilizer determines its usefulness. Plants take up dissolved nutrients, not particulate matter. So, various fertilizers, some are designed to quickly release their nutrients into solution and be available immediately to plants. Something like a liquid fertilizer is an excellent example of a quick release nutrient solution. You may do that for various plants that look a little peaked and you want them quick perk up, usually around like annuals and things like that. These products are like Miracle-Gro and Peters and other brand names such as this. But just because a fertilizer is granular does not mean it's slow release. It has to either be coated or naturally slow to release its nutrients into the soil. Some slow release nutrients include manures from animals, compost. I almost really kind of have to be careful here. Compost is not really fertilizer, but it does release nutrients slowly to plants over a long period of time. Compost is best thought of as a soil glue that holds on nutrients that will be then assimilatable by plants over time. Natural minerals. Many of the organic gardeners will use natural minerals to supplement various key elements for plant growth. Then we have coated fertilizers. These are usually coated with either sulfur or some kind of resinous-like material. Let's end part 3 of soil, the home for the plants.